All right, welcome to chapter 8, editing. Normally, I've always skipped this chapter, not because editing isn't an important technique to learn, but being in the geosciences, we have a tendency, especially, at least I do, to kind of rely heavily on raster work as opposed to editing. However, being that we're making the leap to ArcGIS Pro and the new book and everything, I decided to add this chapter in for several reasons. Again, one being that you do need you have to know how to edit. I'm kind of relying heavily on the book this particular semester, but what I've found is a lot of the students that have taken my course and gone on and done other things with GIS, editing is a huge part of what they do. And I felt like I was kind of glossing over it just because maybe I don't do it very much. But in the real world, it's something that you're going to definitely need to know how to do. It's not always fun, depending on what you're doing, give you carpal tunnel. It's a lot of clicking. But the techniques aren't difficult, and like everything else in GIS, they're making it easier and easier to get things like this done. Now, editing encompasses a lot of different things, and we're going to cover both what you can and can't edit, how to edit things, within the confines of the program, and setting things up ahead of time, and then some other ancillary things that sort of coexist with editing, like annotation and stuff like that. So we are going to do this chapter. You're going to be quizzed on this chapter and things like that. So I think going forward, I'll probably keep this chapter in there again because it's better for you to know at least what you're doing a bit more than I covered it before going out into the real world. So what is editing? So editing is updating existing features or creating brand new ones. Um, it might include creating new features, modifying features, editing attribute tables. It's a lot of different things, and you kind of have to know how to weed your way through these things to get these jobs done. You'll hear the term digitize, which is just a fancy term for trace. Sometimes that's what you're going to do. You're going to, carefully trace along, let's say, an image to map in a line for a road or a railroad or something like that. Or it could be making sure that your topological integrity is being maintained, which we'll get to in a bit, in terms of where streets cross and end nodes and vertices and all these other things. But the point is you want your map and your data to reflect as close as possible to real life. So if you, let's say an engineering firm is going to use this data, they can, use it to plan, let's say, where a building is going to go or this or that. So there's a lot that goes into editing, and you have to make sure that the edits that are taking place are logistically correct, and they reflect what's going on in the real world as close as possible. So this term topology that you'll hear me say is it refers to all of the spatial relationships between features. What does that mean? So if you have points, lines, and polygons, and they represent something in real life, they have to mimic almost exactly what they're trying to map. And maybe a few examples will make more sense. If I have roads, they need to connect. You don't drive on a road and all of a sudden there's a gap, right? So you can see that in this top image, you can't have a gap like this. They must be connected in order to maintain your data integrity, because that's the fact that they're connected is what's going on in the real world. Your data has to reflect that. Polygons must share an identical boundary. And you can see that in here you have overlaps and gaps. Okay, that doesn't happen. If you have state boundaries and you drive from Milwaukee down to Gurnee, there's no gap between Wisconsin and Illinois. Sometimes we wish there was, but there isn't. So the idea is that proper editing techniques need to ensure that all of this topology is logically consistent. Excuse me. It must be it has to be identical to what's being going on in the real world. So how does the program help you in doing this? One of the ways is called snapping, and this is a real nice way of the program understanding, hey, I'm trying to connect things together And as if you set these things up ahead of time, or you can use the default values, it makes a life a lot easier. So if you look in this diagram here, we have we have line A that is right here. We need to connect line A with line B and C. Line B isn't connected yet, and neither is line C. Now what this dash circle represents is the snapping tolerance. So outside of that dotted circle, the program, you're clicking on something, you're dragging it, it doesn't know what to do with it. But once you get that within the confines of this dotted circle, the program knows, hey, I'm trying to connect these, and it'll sort of suck it up and actually add it, connect it where it needs to be. So the snap distance, the snap tolerance is the amount of area that the program understands. Outside of that area, you're just going to drag it around, but inside that area, it's going to try to connect them properly. Now you can set this up if, it's usually the default is pretty good. If you make it too big, you might snap things that you don't want snapped. And if you make it too small, your mouse cursor is only so precise, it might be really hard to snap things together, or you'd have to zoom in really far. And so the idea is to find a kind of a balance between your snapping tolerance being too small or too big. Most of the time, I'm sure the default is pretty good. So there's three kinds of snapping. Now, why are there different kinds of snapping? Well, when you're doing editing like this, you want to maintain that logical consistency. And one way to do that is to tell the program explicitly ahead of time what you're trying to do. If you know that you're connecting lines where they can only be connected to the ends, let's say a pipeline, for example, you're not going to put pipes right in the middle of each other unless if there's a T-junction. But a lot of times with piping, that isn't the case. You're usually connecting one pipe to the end of another pipe, right? So the first idea is end snapping, where the new line will only snap to the node of the existing line. You can see that here up on top in section A here. So once you're dragging your line within the confines of this dotted circle, if you have end snapping on, it'll only snap to one of the two ends. That's it. Now you can also have edge snapping. Edge snapping will snap a new line anywhere along an existing line. You can see that in the middle here. So as long as you get that within the snapping tolerance, it'll snap it to the line, and then you can sort of drag it up and down to where you need it. Now that's okay for some applications, but typically the nodes themselves, the vertices there, are there for a reason. So um, as you can see in these diagrams, there's more than one vertice. You have the top vertice here, here, you have a middle one, and then you have a bottom one. So typically, if you've set all this up ahead of time, you've taken the time to do this, you're probably going to want to snap it to one of those vertices. That's where the vertex snapping comes in. So it'll only allow you to snap new lines to the vertices of the previous already created lines. And a lot of times this is the best option, just because you know it's going to snap to a vertice, which is what you want. However, it gives you some flexibility, whereas the end snapping, is a bit more specialized, where it's only going to let you do it to the end. And that might be the case sometimes, but vertex snapping is probably usually the best way to go, unless if it is something like edge snapping. But in real world scenario, you can imagine that with edge snapping, um, where do you put this? So you have this tiny little gap between these two vertices. How big is that gap? Does that gap represent what's really happening in the real world? Was it surveyed in? And then maybe you have to actually measure that. So edge snapping, you got to be a little careful with, depending on what you're trying to edit. So in most cases, the vertex snapping is probably the best way to go. So polygons, like lines, need to be consistent as well, and they need to be stored as what are called complete loops. And you need this so the program knows where one starts, one ends, and knows for logistical consistency that there's no overlaps or gaps. That's a huge part of polygons. You can't have those. So you have to make sure that when you're editing them, you set it up such that you don't have overlaps. You have what are called coincidental boundaries. So this is another technique. There's a slide on this in a bit as to how to do this. But the main thing with polygons, and typically these are going to be parcels. Now, if you don't know what a parcel is, it's a building footprint. So when city planners, um, rezone things, let's say I want to put an addition on my house. I get all the proper permits. I put an addition on my house. Now the city has to go back in and adjust the building footprint of my house, which would then probably get reassessed for tax purposes. Okay, so things like that's what people do in GIS in the governmental sectors quite a bit, especially at the city or county level. They're constantly updating the parcel data, the footprints of all the buildings, who's where, is this been torn down or rebuilt or added onto, and those polygons have to be adjusted, deleted, all kinds of manipulations going on all the time. So that's where these techniques come in very handy. Now, when you're editing, there's different kinds of changes that are being made. Okay. There's the schema changes, which affect the structure of a table. So if you're adding or deleting fields, or let's say modifying domains, those are schema changes. You're changing how the data is being put into or taken out of your attribute table. Okay. And I do this quite a bit actually in my terroir, the wine suitability studies, because a lot of times the data I need isn't found at a website. I have to create it manually. So I'm adding fields, I'm manually editing, adding, let's say block number is a good idea. A block number is something that the vineyard owner is going to give. So, this plot of land over here is block 1, and then you have block 2 and block 3. That I can't download that. There might be a hand-drawn map of that, so I have to manually edit those in. There's also editing changes where you're actually changing the features themselves, which then by default changes the coordinates of those features. That's all done in the background. You don't have to recreate that. But if I adjust a line length, or if I adjust a polygon, it has a different area. Now it has different coordinates. All of those things are being handled within the geodatabase. That's why it's so important to keep this data in a geodatabase. Can you do this stuff with shapefiles? Sure. We don't want to do that anymore. Those are the old ways of doing it, and you can't use things like domains and stuff like that. So when you're doing these editing changes, what you need to understand is there's a file lock that takes place. Once you go into an editing session, you cannot do anything else to that particular file until those changes are saved. Now, I'm going to take that one step further. That's kind of interesting. If, let's say, you want to add a field of text, whatever it is, the name of my vineyards. Okay, if I want to add a field, I have to actually add that field outside of an editing session, not inside, even though I'm adding a field. So that's one of those weird exceptions where when you add a field, you have to do it outside of an editing session. You add the field, tell it what kind of data is going to go in that column, and then once you add that field, then you can go into an editing session, excuse me, and literally type in the values you need into the attribute table. However, while you're in that editing session, you can't do anything else to that particular file. Okay, so you can't go edit something else. Let's say on the feature side of it, make the polygons different or something. You have to save your changes before you go and make new ones. So you can't create a new file field until like I just mentioned. You have to be outside of an editing session, have all your edits done before you can create a new field. So it takes a little bit of practice, but it's not that difficult to understand. Now, coordinate systems play a huge role in editing because you're changing the data from what it was originally, right? So you can have all different kinds of coordinate systems. We talked about this way back in chapter 4, right? Chapter 4? Yeah, they renumbered all the chapters. So in chapter 4. So you have to understand what coordinate systems you're working with, and the program's smart enough to know that when you're editing those particular those features, all the changes will be converted in the background to the data's coordinate system. So you don't have to worry about that part of it. Regardless of what coordinate system your map is in, the editing changes will still take place in the coordinate system that the data is in. I hope that makes sense. Because of projection on the fly, not all of your data has to be in the same coordinate system. So, we'll get into editing tips later, but I'm going to just preface, kind of jump ahead here for a second. One of the things I typically do with editing to avoid this type of confusion with coordinate systems is if you know you're going to edit, open a brand new project and just edit that particular thing, save your changes, and then go and make a new project with everything added to it. I typically prefer to do editing all by itself. It keeps all the confusion out of it, keeps any kind of file lock issues that you really don't need to worry about then because you're only editing the one that's on the screen. So things like that. And I'll bring this up in a bit later on another slide. Oh, here it is. Okay. So if you know you're going to start editing something a lot, like if you're going to, cut polygons in half and you're going to make wholesale changes in an editing session, it's always a good idea to make a backup. It's so easy in GIS. You right click copy, right click paste. It'll rename it for you and then maybe put ORIG for original. That's what I do. Always have a backup copy. So if you screw something up, you can go back, or if you have the zip file where it came from, something like that. And the second thing here is I this is what I mentioned just in the previous slide. If you're going to do editing, just do it with the file on the screen that you're going to edit with. Don't add a bunch of junk where you might accidentally change something you didn't mean to. Okay. And here's a big thing. Make sure you save. Save, 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 save. Okay. Um, you can enable time-dependent saving, but if you undo something, that's not saved, and it's just better to save every once in a while. In fact, the time-dependent saving thing was not an option in the old version. That's something I'm a bit new to. But just make sure you keep saving. If you make a few, editing changes, save. A few editing changes, save. I have had students and myself who have made like half hour, 45 minutes, hour or more of editing changes, the computer dies and you got to redo it all. And I can't, I'm not even exaggerating. I had a student who lost like 2 hours of editing because they forgot to keep saving as they went along. And I think the computer in the lab crashed and they had to redo it all. That's a lot of clicking you just wasted. So just make sure you save often. All right, so one of the first steps in editing is you have to sometimes create a brand new feature class to hold the features that you need to edit. This is very common. You'll find this, let's say, in your final project. If you are working in an area that doesn't fit neatly within political boundaries, a good example of that is I think Mount St. Helens straddles two counties. So rather than have to download two of everything, what I tell those students to do is make a big box. Okay, create a brand new feature class, make sure it's polygons, um, and create a brand new feature class and make a square, a decent sized square around your area. Call it your area of interest. I just call it AOI, area of interest, and then you actually edit that thing and make a square, and then you save your edits. You just created a polygon, and then you can clip and everything down to that shape, all your DEMs and all your vector stuff. So that is where you can build brand new um, feature classes, and there's several ways to do this, to at least initiate this. And the easiest way is to right click on your geodatabase, go to new feature class, and then the create feature class dialog box will show up in your geoprocessing tab. So, and that's super easy. And the coordinate system, you already know, by that point you should know what coordinate system you're going to be using, and then you can go from there. So this is a lot of times the first step when creating brand new features, whether it be points, lines, or polygons, it doesn't matter. But make sure you know where it's being saved, and all of your names are legitimate and things like that, and you give it a reasonable name. And you have to make sure what it says, be careful to assign the desired geometry type and an appropriate coordinate system. So if you need polygons and you accidentally put points, or if you need points, you accidentally put polygons, you have to delete it and do it again, which only takes a second or two, but just make sure your geometry type is in order. So in ArcGIS Pro, they've obviously changed around a lot of the menus. So you have the editing ribbon at the main top of the program. And when you click on that, you can see that the tools are kind of broken up into different groups. So you have the clipboard group, which is for cutting, copying, and pasting. Now, some of those are grayed out right now. Depending on, you got to have something, you got to copy something before you can paste it, that kind of thing. You got manage edit groups, which is for saving and working with topology. All right, so um, that's the save button I mentioned earlier. You want to keep saving, keep saving, keep saving. Or you could discard edits if you don't like something. You have the snapping group, which is obviously where you turn on your snapping and the type of options, whether it be end or node or excuse me, end, edge, or vertex snapping. And then you have the features group for opening panes for creating and modifying features. Okay, so this is where, like, if you're going to create a brand new feature class of, let's say, a polygon, you would click the create button and then go from there. And we'll discuss more how to do that as the slides go on. And then you have the selection group, which allows you to for making selections or working with selected attributes. You're not going to do that too much, but it's a good way to sort of do mass editing, so to speak. So this is how it's laid out, and this is something I'm getting used to as well because it's a lot different than the old editing pane that I've dealt with for the last 15 years. So in the contents pane, you now have some new viewing options. You have obviously view by source and view by, layer, but you also have view by selection to see what's selected. That's been there for a while, but now you have view by editing, which is kind of nice because what this does is it allows you to turn editing options off or on, just a checkbox, so you don't accidentally edit something you didn't mean to. So if you have, let's say, 3 layers and you only need to edit one of them, you would turn off the other two. So no matter, even if you accidentally clicked on them, nothing's going to happen. So that's sort of that locking thing that I told you about. I do that all the time in vector graphic programs, so I don't accidentally grab things or move things. And then you can also view by snapping, which is where you can enable or disable snapping for each layer um, that have the highest priority. Again, this is some heavy duty stuff. I would tell you, at least in the beginning, if you're working with a brand new map with one editing file, layer on your map, you really don't need to worry about that much because there's no other data that you can mess with. But as time goes on, you might be editing things with multiple layers on it and everything else. And this is where these options come in real handy so you don't screw up something you didn't mean to. So when I want to create new features, I need what's called the create features um, pane, which will show up on the right side of your screen. It's used to give you the tool options for depending on what geometry you're using. It specifies, okay, so if I create a new polygon feature class called AOI, it'll show up as AOI over on my right side, and then it'll say, okay, so here you can see it. Here's the one called commercial. It's polygons. So here are all the options to create polygons. Okay, most of the time you don't need those. Um, Here it is again over here. This is what you'll see in the create features pane. I almost always use this first one, which is polygon. There's some other options in here in terms of being able to create features, but the polygon one is pretty easy. You click and drag your mouse around to create a polygon. And then there's some options that you can go into by right clicking on the various menus to, let's say, create a perfect square, if that's what you wanted. There's also a tool for that, but um, so it just depends on what you need and what you're trying to work on at the time. So you select a template. The template is the layer that you need. So if you have just the one on there, in this case, commercial, well, excuse me. So over here we have addresses, which are dots or points, sorry, points. And then we have buildings, you can see here, but those are hidden. Okay. And then we have two kinds of they're not hidden. You have buildings, you have commercial, and you have residential. So you can turn these on and off, and just to make sure that you know what you're editing. So you select a template and then you select the construction tool, which is, do I want to make polygons? Do I want to make rounded corners? There's lots of options. These are a bit more advanced than what we're going to probably get into. You might use a little bit of it in the tutorial, but for the most part, you're going to use polygons. That's almost always what I've ever used because it's sort of the easiest, and very rarely do you need just a square, unless if you need a square, but there's several ways to do that as well. So the feature template is a quick access to all of the tools available for that attribute, for that layer. So again, for this particular example here, if you look at this, this is a polygon. So these are the tools that are going to be available. If we were constructing points, you'd only have a couple of tools available for points. Okay. So you can also have multiple templates such as commercial and residential. So what that does is that allows you to automatically assign attributes. That's, again, goes back to the schema. Um, so you can template this stuff. If you pick commercial, it's going to have these values automatically populated in your attribute table. And if you did residential, it would automatically have these values populated in your attribute table. So it's a templating thing that allows you to save both time and maintain that data integrity so you don't have weird values being put in there. That's where your domains and subtypes and everything come in. Those would already be set up before you would do an editing session like this. There's also modifying features. So let's say you already have features, but you want to mess with them. So there's different set of tools for that in order for you to modify, whether it be a polygon or a line or even a point, just moving them. So you have options such as moving, scaling, rotating, aligning, things like that. Um, you can reshape polygons, you can shorten or lengthen or rotate lines, you can move points. Um, so it all depends on what you're trying to do. And all of these things take practice. This is one of those things, editing, that's part of the reason why I kind of skipped over it, is because for class purposes, we don't have a ton of time to really get good at editing. It takes practice. I am not good at editing. I fully admit that. I know how to do it. I know how to do simple things, but editing can become very complex depending on what you're trying to do when you start adding things like curves, or survey level GIS where you have to have exact measurements, road center lines, fire hydrant placement, things like that, easements and buffers and all these things. It really takes practice to get good at this kind of stuff. But the thing I want to stress is the reason I'm adding this chapter again, and I mentioned this earlier, is because a lot of our students go on to work in areas or fields, let's say an environmental consulting firm or the city of Oak Creek where I live, and this is the kind of stuff that they're gonna do. There's jobs all over the southeast Wisconsin that are looking for people that know how to do this type of stuff. You also have the attributes pane, which allows you to edit the attributes themselves within the table. Now, this can be very scary. You got to be very careful with this because you can really screw things up. If you have domains, there'll be the drop-down menus, or you can literally type in there to actually change values. Again, you got to be careful. You want to. This is where you start to get all that power. And you don't want to screw anything up. You can arrange the different editing panes um, to your liking. Again, this is personal preference, but you'll find them. They're all over on, as tabs down on the bottom here. As you work with GIS, you'll get more and more of these. You have your catalog pane, you have your create features pane, your geoprocessing pane. I use the results pane a lot because if you're running tools over and over again, it makes life a lot easier. So you can switch quickly back and forth with the various tabs, and it is really handy that way. And you don't have to close them. They'll stay open if you want them there, and they'll reopen next time you open the project. Everything the way your interface looks when you close the project is the same way it'll look when you open it back up. So that's one of the nice things about, it maintains that as you're working on something. Now, sketches are what are, when you're actually going in and creating new features, they're called sketches. And again, there's lots of tools to do this with, okay? Um, for example, you have, sort of the straight line tool here that's highlighted in blue. You have angles and curves and, all kinds of stuff. A lot of times you're not going to use anything but that first one that I semicircled there. Um, because, like for the cinder cone exercise that we'll do later in the semester, you're literally just going to, click, draw a line, click, draw a line, click, draw a line, and you get the idea. You're going to go around and around. And when you get down to the end, sorry, my tracing skills are not very good. When you get back around in the end, you double click and then you have a polygon, a closed polygon. Okay. So you can modify those. You can delete nodes. If you screw something up, you can add nodes in. Um, so that's how all of this is done. The workflow just takes a little bit of practice because you're never going to get it right the first time. I very rarely. Okay, you can trace things, you can create corners or curves, trace features, which is nice. And then when you're all done, you either finish or cancel your sketch, so to speak. So let's say you finish it and then you realize, man, I just want to start over. You could cancel the sketch, which would just wipe out what you did, or you can finish it and then modify what you did by maybe deleting some vertices or moving things around. So you have complete control over your workflow, which is really nice. And that's how you learn how to do this. This is trial and error. Again, it just takes practice, like anything else, but editing especially takes practice. So as you're creating a sketch and you're adding these nodes, let's say to make a polygon, if you right click on the node itself, you'll get context menus. So you can see here, this middle one, if I click on a node, this is what I'm going to get, this middle one here. Okay, that's the sketch menu. Now, when I make a perfect square, here's what I do. I make a click. I click and I add a dot to my map. I right click on that and I go to direction, which is right here. Okay, that'll allow me to use a value of 0 to 360. So 0 is straight across, so I click 0, and it will only allow me to make a line at 0 angle, which is a straight line. So then I go and I make it as long as I need it. For the purposes of this, the length of it, as long as it encompasses my whole area of interest, then I click again on my second vertice. I right click on that vertice, I go to direction again, and I hit 270. 270 is straight down. There we go, straight down. Okay, so it'll only allow me to go straight down, and then I get down to that bottom where I need it down there, and I click. Now I right click on the third vertice that I put in there, and I do this, square and finish. What do you think that does? Exactly what it says. It squares it off and it finishes the sketch. Now I have a perfect square of whatever size I need. Now I didn't measure any of that. You can measure and do distances, but okay. But that's how you make a quick perfect square around an area of interest that you need. Now you'll notice there's lots and lots of other stuff in here. Again, editing can become very, very complicated depending on what you're working on. In the beginning, in the little bit of editing I do, I don't need all of that stuff. I just don't. But if you start going to work, let's say for a city government where you have parcel data and things like that, those type of more advanced tools are going to save you time. They're just going to save you time. If you have roads and you need to make a parallel line to that road, well, lo and behold, there's a parallel tool or a perpendicular tool. It takes all the guesswork out of the angles. So you're not accidentally doing 88 degrees as opposed to 90. So these tools are there, again, to save time and maintain data integrity. But you can also see there's lots of other options here. The general editing menu is this first one here, A. And then D is the dynamic constraints. So what that is that's telling do I want to delete a vertice? Do I want to finish or finish part? That's another thing we haven't talked about is finishing a part, okay? Where a perfect example is Hawaii. Hawaii is made up of multiple islands, but we only want one row in our attribute table to be Hawaii, right? So in the states attribute table, you have 50 states plus District of Columbia, so 51, and Hawaii is one record. That's because even though it's how many islands, I think it's six maybe, how many islands, it's a multi-part polygon because they're not continuous. It's a multi-part polygon, which makes it one row in your attribute table, all called Hawaii. So that's where, if you need multiple pieces, you can do finish part and then you go on to the next one. Finish part, go on to the next one. Finish part, go on to the next one. And then when you get all of those done, let's say we're doing Hawaii, when you get all the islands circled or digitized, then you click finish and your whole sketch is done, and then you have one happy record within your attribute table. The general editing context menu is the one that when you select is active and you right click on the map itself. So when you're in an editing session, you right click, this is what it allows you to do. Things like copy and delete, and you're not going to use this a whole lot, but one of the things you're going to do is probably you might want to click on edit vertices, which is down here in the second. The whole point of this is to start editing, to, you know, you want to actually get going and adding or modifying your features on your map. So that one, it's semi-useful, but a lot of the stuff that's in there, if you know you're going to go edit, you're going to use the editing tools right from the get-go. You may not even need this context menu. Now the sketch menu I mentioned before, this is where basically all the drawing tools are, if you want to look at it that way. They're construction tools. And it allows you to do lots of things. If I'm doing points and I know the exact value in, let's say, my two-dimensional coordinate system from Latin Lawn or whatever, from a GPS where my well is, I can do absolute X, Y, and Z. Maybe I don't have the Z value, but at least the X, Y. I can tell it exactly what those points are, and boom, it'll be on my map. All right, so you're not going to necessarily use all of these tools, but they are available. So, and I already mentioned you how I do sort of the square. That's just one way to do it. That's the way I learned how to do it, and that's the way I do it if I need a square. Otherwise, a lot of times it's just sort of freehand, like when you're doing your cinder cone exercise, you're just kind of using the topographic lines as a guideline to sort of mask out where your cinder cone will be for a polygon. We'll get to that later. But that's what you're going to do. That's about as much editing besides this chapter as you're going to do in this class. You also have the dynamic constraints menu. Okay. Again, this is something that you're not going to use a whole lot. This type of stuff is heavy duty into parcel editing and almost into engineering in terms of making sure that all your directions and distances, if you're using survey grade data, things like that. So I'm going to kind of gloss over this a little bit, but just know that these are a bit more advanced tools. And then I mentioned again the vertex menu. You can, if you make a mistake, you can delete that vertex. If you're all done and you'd like to add a vertex in a spot, you can do that. You can move vertices. You can do a lot of different things with these tiny menus like this. Again, you can right click to delete it, right click to add it. You can finish a part. So you'll see this as you go along, and it's pretty easy to get the hang of as you go. There's also the snapping toolbar, and we've already talked about snapping. So this is kind of where you turn it on and off and what type of snapping you're looking for. Um, so it's just, these are highly specialized types of things. For most purposes, at least in this class, you're not going to need this that much other than in the tutorial itself. I'm not going to make you do this on a test or anything like that. But it is good to know where they are, where the snapping options are, and which ones, kind of get an understanding of what they all are. Now, going back to our discussion about logical consistency, when you're creating polygons, they have to have that shared boundary. It has to be sort of a closed loop in terms of the program. So here's how you kind of do that. And you'll probably do this in the tutorial, I think. You draw a polygon, so you draw the whole thing all the way around. La 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 la. Okay, my perfect polygon there. Then you want to create an adjacent polygon. You start with the first node inside the first, for the second one inside the first one. You make your drawing and you make the last node inside the first polygon. And when you do that, they now have coincidental boundaries. Okay, you have to use the autocomplete polygon construction tool. That's the caveat to this. That's a separate tool on the toolbar. And that's fine. So you start inside the existing polygon, create your shape, and then once you you end inside the existing polygon, they now have a closed shared coincidental boundary, which is what you need. You want that logical consistency. So it's pretty easy. It's, it makes sense when you kind of look at it like this, that you just, create one, start on the inside of that one, end on the inside of that one, boom, you're done. As long as you use the autocomplete polygon construction tool for the second one. So you can create additional adjacent polygons, in the same way. You create the first one in A, then continue adding adjacent polygons with the autocomplete polygon tool. So I start here, I go around, sorry, and I, finish there. And then now I have that one. Now I can start in this first one and then the very first one. Okay. Now you can't do this if there's a gap there. That's what that's there. You must have it enclosed in order to create a third one per se. You won't be able to create, this does not work where you have a gap already there because the program won't know how to complete it. So in order to do this technique, you have to have coincidental boundaries already set up. And just remember, in order to do this, you have to use the autocomplete polygon tool for the second or third or fourth polygons that you're creating. The first one has to be just the regular polygon tool. It's pretty easy. Even I know how to do this, and I hardly ever do these. You can also split polygons. So this is um, a neat way of being able to, let's say boundaries change, somebody buys a property and now it's owned by two different people, things like that. They're subbing out various properties. So you could do that with coincidental boundaries the same way. You start outside, you create a line through it, you end outside, and now you have one, two. Let's see if I can make it two here. Ta-da! You can make two new polygons. Now, going all the way back to week one, this is exactly why you use geodatabases, okay? Now, once I do this, the geodatabase, because this is being stored in a geodatabase, the geodatabase automatically recalculates the areas for those two polygons. Okay, so the original polygon had let's just use simple math, had an area of 1. I cut it in half. Now the area of polygon 1 is 0.5 and the area of the other one is 0.5. It recalculates it for you. Shapefiles won't do that. You'd have to manually do that. That's what makes one of the reasons why geodatabases are so powerful. I could cut that thing again. Now I have 4 pieces. All right, so I have 1, 2, 3, 4. You get the idea. I'm trying to draw here. It's not very good. All right, so each one of those, we'll just assume they're equal. It would be 0.25 of the original over here because the program's going to automatically recalculate those in the shape underscore area field. That is one of the huge benefits of using geodatabases, especially in our world where we're looking at things like, watersheds and geological units and all this kind of stuff where we need areas to understand, what's the contamination limits for a spill or, stuff like that. So this is where that fancy folder of a geodatabase becomes hugely helpful. So when you're editing maps, you have to maintain map topology. So that way, when you're modifying features, the logical consistency is maintained. So if a polygon is edited as it is being in version A here, you have this gap that's created right here. Okay, so that's not good there because there is no gap there. So the map topology enables adjacent or connected features to be edited simultaneously. So as you're editing that, it's automatically creating that thing in order to maintain that there's not a hole there, there's something there, but it'll help you maintain the fact that it's going to recalculate areas and things like that. So this is where setting up all your map topology, if you know you're going to be in an editing sort of environment, is hugely beneficial. So when you're using map topology, you can use what's called editing edges, which allows, a shared boundary is called an edge. So that makes sense. And when you're modifying, let's say polygons, the tools have what's called an edges tab that allows you to use map topology. So you can see here in version A, this new polygon is created, right? So that's great. But the problem is we have this gap right here. So by switching to the edges tab and modifying the edge, it automatically fills all of that in with this brown color to maintain the edges correctly, the coincidental edges. So that it's a bit of an assumption, but that's how this works. The program, if everything's set up correctly, the map topology is maintained by automatically filling in areas after you've made a change. So it works pretty well. It's a huge shortcut than having to make changes to the original pink one up here in A and then having to move the brown one over. The brown one's automatically sort of sucked up to the edges using the map topology rules. You can also edit nodes with topology for things like lines where you have to make sure everything stays connected just logically, um, street intersections are maintained and things like that. So you can use the edges tab of a modified tool the same way to make sure that things are moved exactly where they need to be. You can uh, stretch geometry proportionally, or you can move things smoothly. Again, I haven't done a lot of this, I'm being honest, and this stuff takes practice, but I wanted to introduce this to you because you will see this stuff eventually in the real world a lot of times. Okay, so another thing that you can do with sort of editing, an editing session, is what's called annotation. Now we may have talked about this earlier. Annotation is your labels for your map, right? So if you turn on the labels for your map, for let's say the state names, okay, or maybe county names, but you don't like where they're placed always based upon the placement method, you can actually create what's called annotation and save those as sort of a map pane uh, class. It's stored in a feature class with the attributes and everything already in there, which allows a couple things. It allows you to reuse them over and over again, which is nice. But annotation also allows you to have complete control of over where they're placed, and the labels can be manually edited and things like that. Now, typically, I've always used annotation um, just in the map itself. But if you're going to save it in the geodatabase, then it does require you to go into an editing session to make changes to that annotation. So again, annotation are the labels you put on your map. You write once you have all the labels on your map, it's a simple matter of right clicking to say create annotation. Now they're being saved as an annotation feature in your geodatabase where you have complete control over what they say, what they look like, and where they're placed on your map. And because a lot of the mapping I do doesn't require a ton of labels, I use these quite often just so I can kind of move things and tweak things. If I have 5 labels, you know, and it's easy enough to just move them to where you want them and not necessarily just, oh, the program's going to put them here. Well, that's great, but it may not be where I want them. Maybe it's a little OCD. But the idea being is with annotation, you have complete control over where they are, what they look like, and everything like that. It's just now, if you're saving them in a geodatabase, you have to go into an editing session in order to do anything with them. Now, the reference scale is something we haven't really talked about. So when you add labels to your map, those labels, let's say they're 12-point labels at 1 to 24,000. So if I zoom in or out, the labels will get bigger, it will stay the same even if I zoom out. Okay, so you can see that here in A, this is what they look like when I first add them to my map. I say, okay, let's add the labels to my map. No reference scale set whatsoever. I'm just going to add them, and that's what they look like. So if I zoomed in, they're going to stay the same exact size. Okay, so that looks kind of weird. If I set the reference scale, which the reference scale is the scale at which the labels will always appear at the correct size. So if it's 12 point at 1 to 24,000, then if I zoom in or out, excuse me, the labels will either get bigger or smaller depending on whether I zoom in or out. Um, this is more used for online versions of maps. If somebody's going to use them in a digital format, you wouldn't necessarily have to worry about this too much if you're printing a map or things like that. But it can be handy. It's just right click. Once you know you have your labels the way you want them and the scale you need to be at, right click, set reference scale. It's that easy. And you can always turn it off or change it if you want. Um, but this is more for online map viewing than anything else. To create annotation, it's super easy. You turn on the labels for all of the layers that you want annotation set up for. Now be careful with that. If you only want annotation for one layer, then only make sure that that layer's labels are turned on. Once you have them turned on, and they appear at the scale you want them at the size you want them at, then you can convert those dynamic labels to annotation and save them in a geodatabase. Okay, when you do that, okay, and here's the dialog box for that, you have some options like convert unplaced labels to unplaced annotation. By doing that, it allows you to pick and choose, like if labels start to overlap, the program will say, hey, I have a conflict here. I'm going to set this one aside and put it in what's called unplaced annotation. And it'll do that for any conflicts that it comes across. Okay. So once you have those conflicts, they get set aside, get placed in unplaced annotation. And then you have the option of what you want to do with them later on. If they're labels that just don't mean much, you can delete them, or you can place them later and then move them around. Remember, annotation, you have complete control. You click and drag it wherever you want on the screen, or you can edit them later. So typically, you're going to want to keep this option here. Okay, but you just give it a name, tell it where it's going to go, and things like that. And it's super easy once you have them on your screen. Again, for most cases, especially in my world, I might have a dozen labels. That's a lot for me. I don't turn on a lot of labels because typically I'm mapping natural phenomena that where addresses and buildings and stuff. I just don't mean much if I'm mapping floodplains. I don't need maybe I need the name of the floodplain or the name of the geology eventually, but a lot of times that's just not what I'm trying to do. So if you already have annotation created and you just need to add like one more, you can do that with the Create Features pane, where you have different construction tools to create, horizontal or curved annotation, and then you can have the labels follow the previous rules and stuff like that. This is very specialized stuff. Typically, you're not going to do this unless you forgot to label something or you just need another label on there and you want it maintained in your geodatabase. So you're not going to use something like this very often. All right. So that's the end of what chapter are we on? 8. Again, they renamed all the chapters, so I'm a bit confused. I hope some of this made sense. Typically, I've never lectured on this particular chapter. I've only assigned parts of the tutorial just to give you an exposure to editing. but I'm going to rely heavily on the book this semester, being that this is the first time I'm using it. And plus, it helps me to understand better how to do this stuff in the new program. So I hope some of this made sense, and the tutorial should solidify some of the things that I talked about um, in in this particular chapter. There's a lot of things that, like with editing, that just take practice. I do a lot of raster work, and a lot of that is just running a tool, right? I run the hillshade tool, or I run the overlay tool, or the map algebra tool with overlay and stuff like that. Editing is something that there's so many tools available, and a lot of them are very specialized. But this is something that definitely does take practice. And because of the world I live in, I just don't get that kind of practice with it. But I wanted to make sure I made the decision. Again, I'm going to repeat myself. Many of you might go on to jobs out in the real world, environmental consulting or something like that. And editing is a real part of GIS. And I don't mean to minimize it. It's just over my GIS career, I just haven't had the need to do a ton of it. I know enough to make myself dangerous, so to speak, but by all means, editing is very important to understand how to do, and at least basic editing skills. There are some very advanced editing skills as well. And in the previous versions of this book for this course, there was a chapter on advanced editing, which I never covered because I didn't even cover the regular editing one, but that's where it went into how to make curves and things like that. So you can imagine if you work for a city and they're doing survey grade GIS, where every millimeter counts, because you don't want somebody digging up something and breaking a fiber optic line, or worse yet, digging into a gas main. So the measurements have to be precise, and that's how these types of things are done with these advanced tools, where measurements are being done as you use the tool. So if somebody goes out there and surveys it to the nearest centimeter, you have to be able to replicate that in a map to that very exact number. Um, you know, and they have tools for that. So it's much more on the, for lack of a better term, engineering side of things, but it's definitely a skill in GIS that you should know how to do at least a little bit. All right, so chapter 9 is coming up, which is queries, which is odd because that chapter used to be chapter 8 and was actually covered on the midterm, and it's not anymore. That's a great chapter. I think you'll enjoy it, where we start getting into finding some really cool, you ask the data questions in different ways and get really cool answers. So, all right, that's it for chapter 8. Take care. Thanks.